yeah, let's just get into it. So, PlebDevs workshop, LNURL Pay. So this is going to be basically a soft intro to LNURL, and we are going to make our pay endpoint, which will allow other people to request invoices from us without us having to do anything. So that's kind of the main advantage here. So link to the slides. First of all, the slides that I'm going through right here, which has the code and some other information, you can find it at this link. You can save it and you'll always be able to view it. And then right here, this is actually the completed project for this workshop. So you can go here to see that, but we're still gonna build it from scratch here either way. Okay, so prerequisites. What I expect you to know for doing this workshop is basic knowledge of JavaScript, basic knowledge of Bitcoin and Lightning, Git and GitHub, and then we'll talk about this a little bit more, but a Lightning node with LND Connect capability or Docker with Polar. And so this is basically like we need a Lightning node and we need one that has this LND Connect capability, which is the ability to take all of the connection informations and permissions informations, and it kind of turns it into a URL for you. And it makes it's just an easy method for connecting a app to your Lightning node in kind of a secure standardized manner. So that will be a requirement here. You know, we have other workshops covering intros for all of these things in the courses as well. But yeah, I mean, I can't go through everything from scratch every time. So just gonna assume you know these things, and if not, check out our other workshops, videos, content, courses, etc. Okay, so overview, what we're gonna do, we're gonna talk about what is LNURL, what is LNURL Pay, what is Lightning address. We'll peek at that. We're actually not gonna build our Lightning address today, but you'll have enough from this starting project where it actually won't be that much to add a Lightning address. So we'll just look at that. We're gonna build our LNURL Pay server. We're gonna deploy it on render for free. And then I suppose I'm gonna test this in prod, and I'm gonna try and send myself a payment because I'm gonna be hooking this up to my real Lightning node. Okay, so let's get into it. So what is LNURL? LNURL is a protocol, basically a set of standards or a set of rules that connects Lightning Wallet functionality through an HTTP server, which allows for easier integration of Lightning payments into apps. So it connects Lightning Wallet functionality. So basically, for our sake in this workshop, the functionality that we care about is creating invoices. Creating invoices isn't something that I want to protect too much on my node. I would love for people to create invoices to pay me. That's fine with that. So with LNURL and LNURL Pay specifically, we're going to be setting up a service or a server that sits in between our node and anything that's trying to interface with our node, and will basically act as a gateway to help us interface with our node, let anyone do it, whether it be Alby or Stacker News or whoever wants to pay to your Lightning node. So the LNURL is essentially, it's a domain/endpoint that is encoded with Bech32, the same encoding scheme used for SegWit addresses. So we're gonna make this server. This server is gonna have a domain, and then we're gonna encode that with Bech32, and that's basically what the LNURL is. And that Bech32 encoding, that's what you actually scan on a QR code. So like when you're scanning an LNURL to pay someone, you scan this QR code, your wallet knows how to talk to an LNURL server, and it's able to ask you, okay, how much do you want to pay this person? Or there's other actions that you can do that we won't get into, such as withdraw. You can withdraw from an LNURL. You can make a request to open channels and stuff like that. So it's really cool. The protocol is an open source project available on GitHub. As of this date, it contains 20 documents, each called a LUD or LUD, an LNURL document that describes different pieces of the protocol that wallets and service providers can implement. So, you know, just like how Nostr has nips and Lightning has bolts and Bitcoin has bips, these are just, these LUDs are just descriptions of the protocol, of different parts of the protocol and the rules that you need to follow in order to have a wallet actually be able to request and go through the full flow with your server. Okay, so something else, we've actually done a LNURL auth workshop in the past, because that's something else you can do with LNURL is have an authentication flow. And we'll probably go over that again at some point, but starting with just LNURL and the pay endpoint, I think is actually the more simple place to start. Okay, so why LNURL? Essentially TLDR, it's payments without interaction. That's kind of how I see it. There's a lot of ways that you could talk about the advantages and disadvantages of LNURL. People have a lot of thoughts, but pretty simply, this is how I see it: payments without interaction. So with a traditional payment flow with Lightning, it would look something like this. Maybe you're a creator, and I'm like, hey, I want to pay you 100 sats. So I have to reach out to you and tell you that. You generate me an invoice for 100 sats. You send me the invoice. I pay the invoice, and then you can see on your wallet that it was paid. So there's kind of this handshake process that needs to happen in a traditional payment flow in Lightning. And LNURL just takes that payment flow and it kind of abstracts it away to make it synchronous, or asynchronous rather. So only one person needs to interact. So the LNURL payment flow, I want to pay you 100 sats. I scan your LNURL with my wallet. I can set an amount that I want to send you, and then I confirm and I just pay you, and it just happens. So that's cool. So the person that's receiving, if you have an LNURL server, that means that you can set it and forget it, and then people can pay you, versus needing to always be interacting with people as they want to pay you, which has a ton of friction. Okay. So problems that LNURL and the Pay LNURL spec specifically solves. So easier interfacing of node functionality with apps. So once again, this is the idea of your node or certain aspects of your node being able to communicate with an app. This is something that's traditionally it's been difficult in the past, and difficult today is still in some ways, but something that stopped people in the past a lot was Lightning nodes usually communicate over TCP sockets, basically just another layer of the internet protocol, versus HTTP, which HTTP, those are the servers, the APIs that we're used to that most of the internet communicates over that standard. So it's this simple mismatch of standards where most apps use HTTP and they couldn't really talk to the Lightning node without having some kind of proxy or service in the middle that could take the HTTP traffic and turn it into TCP traffic, and you know that whole flow. So it was a little bit complicated. There was a few steps in it. So LNURL helps act as this standardized interface or gateway between your Lightning node and other apps and services. So yeah, it abstracts the node's interface for public interaction. So with my LNURL server, I can let people kind of interact with my node without, and kind of give it a public-facing endpoint without having to worry about too much, because I'm just going to be serving them invoices that they can pay and verify. So it allows for setting an amount at the moment of payment. Instead of upfront, you have to tell me how much you want to pay me, and I generate the invoice. So it fixes that issue. It enables us to have a static QR code of the LNURL for receiving while still generating a new invoice for each payment. So that's really cool. It's like that dream of having just a static QR code that you can tattoo on your body that people could always scan and, you know, pay you through it. Don't get this tattooed on you though. It's a little early. Bolt 12 also solves this issue, which we're going to have a workshop on Bolt 12 at some point. So finally, enables a human readable Lightning address. So Lightning address is just another little layer of abstraction that goes on top of an LNURL Pay endpoint. And that's something we'll build in the near future. But it's really easy to add that onto an already existing LNURL Pay endpoint. Cool. So now we're actually going to get into the spec, and we're going to start by looking at LUD 01 here. Should we go over these bullet points first? Let's go over this bullet point chart, and then we'll look at the actual spec, which is right here. So what is LNURL? It is a bec32 encoded https/onion URL. So it's just a URL that's encoded with bec32 that makes it look similar to a SegWit address, because that's the same encoding as a SegWit address. So it enables a standardized interaction between a wallet and a service. This promotes additional services or improved user experiences. So the wallet, that's the phone in this example, and the service, this service is basically our server that we are going to have that communicates with our Lightning node. So that's all it is. It's just a gateway that stands in between any wallet and app and then our Lightning node. Okay, and it is a URL. It's formatted as bec32. So that's what we know so far. Okay, so kind of makes sense. So case handling, LNURLs can either be all uppercase or all lowercase. That's fine, not a big deal. Mixed cases not allowed. When used in QR codes, they should be uppercase though. So it's good to know. I think our code just is going to default it to uppercase. So regular URL looks like this and can be converted to a bec32 encoded LNURL and presented as a QR code. If an LNURL contains the tag query parameter, it holds a special meaning. Actions depend on the tag value. There's no tag, a GET request to the decoded URL should yield a JSON response with the tag field. Actions again depend on this tag value. Okay, so let's dive deeper into this now, into the spec. So I'm going to jump over to the browser. Can we still see this? Yes. Okay, so this is kind of what we read through here. LNURL, it's bec32 encoded. You take an example URL like this. Let me zoom in. Example URL like this, and you turn it into this encoded string, and then you can present it as a QR code. So once it's decoded, if the tag query parameter is present, then this LNURL has a special meaning. Further actions will be based on the tag parameter value. So this tag is what actually determines what can this LNURL endpoint do. So we're in LUD 1 here. This is just the base spec. So it's just defining basically the encoding and the decoding. So there's no functionality in this. It's just how should you encode this, and what should you expect in the near future. And they give us some code examples here in Scala and JavaScript to, what is this, encoding to decode a bec32 LNURL. Okay, cool. So that's pretty simple. So we create this encoding. When someone scans the QR code, they make a request to the URL that's encoded, and that URL will return a tag which will tell them what they can do. That's essentially what we know so far. Okay, so not too complicated. So back to LUD 1. So we went over all of this. Okay, so now LUD 6. So purpose, LUD 6 is our actual pay spec for doing the asynchronous payments. So the purpose here, wallets can scan a static QR code or click a static LNURL to get payment details. These details may contain extensive metadata, more than a regular Lightning invoice. So that's another benefit right there, that it kind of lets you expand what data you can wrap around a certain payment. So payment amounts may be fixed or range bound. So another huge advantage there. So LUD 06 payment flow. So should we walk through this first? Yeah, let's walk through this first. So a user scans an LNURL QR or pastes the LNURL link. The wallet decodes the LNURL and sends a GET request to the service. The service responds with a JSON of certain details, For example, the max and min sendable amounts, metadata, and a callback URL. Okay, so let's actually go to the spec from here, so we don't get too ahead of ourselves, too lost. So basically, when you scan this LNURL, this original LNURL that we made here, what do you expect to see? Well, this is basically the response that your wallet will get. There's a callback, there's a max sendable, a min sendable for the amount of satoshis, actually millisatoshis. There's some metadata, which we'll talk about, just additional data that we want to include here. And then here's this tag from the first part of the spec. So this tag right here is for pay specifically. There can be multiple tags, but this one is telling us that our LNURL server is set up for the pay spec. So when your wallet sees this, it knows that it can make a request to the callback with a specific amount. Cool, so let's go back to the flow. So this is the response object we get. It tells us with this tag that it can be paid, and then if we want to pay, we make a request to the callback. And of course that has to be within the sendable range. So back here, oh yeah, and just, if you have questions or if you're getting lost, drop them in chat. Feel free to do that, but keep going here. So let's go through this flow chart here. So the wallet sends a request to the LNURL, so it basically scans the QR code and it makes the request. Our LNURL server responds with that information. And then the wallet informs the payment amount, and it sends that to the callback, and then the LNURL server will then talk to the Lightning node, it create an invoice, and then send that invoice back to the wallet. So this is the full flow there. It's just basically, it's a request, it's kind of a handshake back and forth process, but our server is doing the manual work that we would otherwise be doing. So the wallet shows dialog with payment details, and the user specifies an amount within the provided range. The dialog shows the domain from the LNURL and the text plain metadata. You can also put an image in here, but we're not going to do that right now. So for the invoice request, the wallet sends a GET request with the specified amount to the provided callback URL, and the service responds with a Lightning invoice or an error. So, this LNURL that we're posting up, it's basically just a advertisement for, hey, come and interact with my Lightning node, and here is what you can do based off of this tag, which ours is just going to say pay at first. So it's like, here's all the information that a wallet needs to know to interact with our Lightning node and to pay us. So a final step in the process is the invoice verification and the payment. So a wallet ensures that the H tag in the invoice is a hash of the metadata. We'll talk about this more in a second. It checks that the invoice amount matches the user specified amount. If all checks pass, the wallet pays the invoice without needing further confirmation. So the wallet's basically it's doing this verification step where it's verifying that it's not getting scammed or spoofed a payment. And so that kind of occurs, well, it mentions it here at the top. So choose an amount that is not fixed. The wallet will call the service and get a Lightning invoice specific for that payment containing a hash of the metadata as its H tag, which is the description hash. This is just part of the information that helps us create a Bolt 11 invoice, and then proceed to pay the invoice if it matches the expected amount and the hash matches. So basically up front, we provide in the metadata information that we will hash and that the wallet can expect that to be hashed for us to prove that we're making a new invoice for the wallet and it's a legit invoice. So the metadata array, more about the metadata, must contain one text plain entry. All other types of entries are optional. Metadata is a JSON array, must contain either one image entry one JPEG entry or neither. The metadata JSON array is only allowed to contain arrays. The first item is the metadata array, is always a string representing the metadata. So for us, we're basically just going to have this thing right here. So our metadata is just going to be text/plain, and it's going to say, here's our example LNURL endpoint. And so you can see their minimal example here, so it'll look something like this. And then more on the verification. So this is what the request will look like for the invoice. You request the callback and you put an amount query parameter to get the specific invoice of that amount back. So this will be, I promise, this will feel very simple when we're walking through it. Okay, so here, number 7, LN wallet verifies that the H tag in a provided invoice is a hash of the metadata string converted to a byte array. LN wallet verifies that the amount is the same, and then if both of those check, it pays the invoice. Okay. So for step 7, it's actually funny. I have found some wallets that do not do this step, do not verify the hash. I know that because I actually made this endpoint incorrectly at first, and it still worked. But yeah, so this was something that was a little bit new for me, but we'll see exactly how this works in our callback endpoint. Okay, so that's a bit about the spec, the LUD1 and LUD6. So this flow right here is what we need to keep in our mind. We scan the LNURL. We get information about, the wallet gets information about what it can do with our LNURL server. So that's this step. And then the wallet can request a payment amount. We create that invoice with a hash. We send it back to the wallet. The wallet verifies that hash, verifies that invoice, and then it pays it. Okay, so let's start by spinning up a new Express server. And yeah, I'm gonna do this from scratch right here in front of you. And this is code, once again, the links, if you just joined, the links to these slides are right here, tinyurl.com/LNURL Pay workshop. So that's where you can get the code. You can also get the code on this repo right here, LNURL Express. But I'm gonna take this and I'm just gonna spin up a brand new server here. So I'm gonna go to desktop, and I'm going to make a new directory. We'll call it LNURL Express Workshop, and I'll cd into cd LNURL Express Workshop, and I'm going to run npm init-y. And so this will just, let me zoom in a little bit. This will just initialize a new node project. So it'll generate a package.json, and then we'll be able to install packages. So I'm going to do that. Okay, here we go. And then now I'm going to do git init, because I want to initialize this as a Git repository as well. Cool. And now let's actually, yeah, let's just open it up in VS Code. Got some epic sci-fi music in the background here. It's inspiring me. Okay, so we need to install a few packages first. Basically everything right here at the top. So we have Express Beck32, body parser. I believe crypto, we don't have to install that. Let me check. No, we don't need to install crypto. That comes with Node. And then we're going to install cores as well. So let's do that. I'm going to open up the terminal in here. And I'll do npm I express body parser cores and Beck32. Okay, cool. So generated node modules, package lock.json. Now I'm going to create an index.js. It's going to be where our server lives. I'll zoom in a little bit. Cool. All right, and I'm just going to copy this code right here, and we're going to walk through it. Okay, cool. So this is just going to spin up a basic Express app. So we pull in the Express library. So in case you don't know, Express is just a very easy, popular to use library with Node.js for creating servers and APIs. So we're able to say app equals Express. We invoke Express. Body parser.json. Here we're just telling the Express app that we're going to be using the JSON format. That's very standard. Cores, these few lines right here, this has to do with some issues I've had from my experience with wallets not being able to request to the server. So cores is the cross-origin resource sharing standard. It's basically a standard for you as a server to set who and how can people request to my server. So we very strictly set cores right here to allow everyone to request from our server, and they can get and they can post. We allow these two types of headers, and then we just allow everything for options. So this is just very open-ended requesting to the server. And then we do app.listen. This is where we're actually spinning up the server, and we tell it to listen on the port, which we have not set yet. This will be an environment variable, or just we use port 3000. Cool. So let's save that. And you know, I'm actually going to make an app. I'm going to make a base endpoint because we don't have an endpoint here. So we can say a hello world, but I like to say I'm live. So put that in there. I'm live. Okay, so that can be our base endpoint, just so we can test our servers working. I'll add that right here. Okay, cool. Let's start our server, and it should work. So to start our server, we're gonna do node index.js. So we're telling Node to run the index.js file. Pretty simple. Okay, it tells us server's listening on port 3000. So now I can go to localhost 3000, and we see I'm alive. All right, so our server is working in the most basic way so far, so that's good. Let's continue on. So next, we're gonna make our LNURL endpoint. So this is that main endpoint that when someone requests it, they will get some basic information about how they can interact with our LNURL server. So let's copy this, and we're gonna paste it in right here below our root endpoint. We'll just start adding endpoints down here, making sure that they're all above app.listen. Okay, so we have our metadata here, our text/plain, and we're just saying this is a sample LNURL endpoint. I'm gonna say this is Austin's LNURL endpoint. So we have a callback. Okay, first of all, here we have this backend URL. This is not set quite yet. So we're going to need to set that. That's going to be an environment variable. We're going to use cores for that. So we have a max sendable, which this is in millisatoshis. And so this is, if I take away 3 zeros, this is 100,000. So at most, people can send me 100,000. And at the minimum, they can send me 1. Oops. Because yeah, millisatoshi is always multiplied by 1,000. We're putting in the metadata right here, and then we have our pay request tag. And so this URL, this is just going to be whatever URL our server is, which right now it's localhost 3000, but we will set that with an environment variable. They can be dynamic. That way, when we deploy it, we can basically reset it, and it's not going to be hard-coded. So let's actually go ahead and do that. Let's go make a .env file. So I can say .env, and I'm going to say backend URL equals, yeah, localhost 3000, just like this. So that's good, and now I need to add, what is it, cores. I need to allow environment variables. No, I think we're good, actually. No, it's not cores, it's .env. So sorry, we need to install the .env package. I forgot about that. So npm i.env. And then I'm going to say const.env equals require.env, and then .env.config. Okay. Small miss there. Let me add this to that first slide. Where do this from? Do it from app. Okay, that'll work. The code's all there at least. Just do a few backspaces here. Make room for it. Okay, there we go. Cool. So we have that in. We made our LNURL endpoint. We set our environment variable as localhost 3000 for our backend URL. And with .env package and .env.config here, this is what basically unlocks it. So let's test our new LNURL endpoint. Just to make sure that everything's working so far. So I'm gonna do node index.js. I'll go back to localhost 3000 and we'll do /LNURL. Okay, sweet. So I see the response I was expecting here. We have a callback. So this is what the wallet would see. The wallet would see, okay, here's someone's LNURL. Here's the most I can send them. Here's the least I can send them. Here's what they allow is payments. And here's the callback I go to request those payments. Sweet. So let's continue on. Next, we will have a get LNURL endpoint with an encode LNURL function. So let's paste this in and then we'll look through it. Okay, so get LNURL, this is basically just going to get our LNURL string. This is not necessarily a standard endpoint, it's just something for us to use to get the LNURL. So what do? We take the original URL here, we throw /LNURL at the end, and then we encode it with our little encoding function, which is just using Bec32 to words. It's making it uppercase. And remember, the spec here actually gives us, if we go back to LUD1, the spec gives us this example code. Oh, this is actually for decoding. But you can find lots of example code for encoding with Bec32 as well. But also this works. So we're encoding in this LNURL format. We're returning it, and then we just return that on the endpoint. So let's save that, and let's do get LNURL. Oh, we probably need to restart our server, huh? Because we just update the code. Let's try that again. Okay, cool. And I now have this LNURL string here. So what can I do with this? I can actually go verify that this is encoded correctly right now using a very cool tool. It's called Lightning Decoder. I was using this earlier. So Lightning Decoder, I can enter a LNURL here and it should decode it. There we go. So we see the same information here. We're basically cross-verifying and making sure that our format is correct. seems to be correct. But of course, this is a local host, so we can't actually interact with this yet, or the wider internet cannot interact with this yet. But we will take care of that soon. Okay, so one more endpoint I believe we need to make, and that is the callback endpoint. Okay. Let's copy this and then we will walk through it. So this is definitely the most complicated endpoint here. And this will also show us what we need left to build for this server. So let's walk through it. So first of all, we are expecting an amount from the request.query. So that means that when people request through us, they will be requesting this callback. So they'll be doing something like callback, yes, just like this, amount equals 1,000, or this is actually 10,000. So they'll send something like this, and that's how they will get their invoice from our endpoint. So that's what we're getting out of here. We're grabbing the amount from the query parameter on the URL. Next, we take our metadata here. So this is actually wrong because I updated my metadata. So let's copy this and move it over. An array inside of an array. Okay, cool. Text/plain Austin's LNURL Pay endpoint. So we take this and we turn it into a string, and then we hash it with SHA-256, and we digest it as hex. And next we turn that into a description hash of type base64. So this is if you're not used to working with low-level Lightning stuff, I know this can look really complicated, but this is essentially what the standard is defining here. If we go back to LUDs 6, so the Lightning invoice for the payment needs to contain a hash of the metadata as its H tag, which is the description hash, right? And so we're going to be using LND here. I probably should have mentioned that up front, but I can go to the LND docs here, and for their API docs, and the add invoice function. This is the function we're going to use to create an invoice. It has an argument right here for description hash, so we have the option to pass in a description hash, and that is exactly what we're going to be doing here for making our invoice. So that is what the spec is defining. This description hash will help create the invoice and basically the preimage to the invoice, which is how you verify the invoice is correct. So you have the hash and you have the preimage to that hash, and those two should be reconciled perfectly. That's how you verify a Lightning invoice, essentially. And so that's what our endpoint is allowing for, by making it standardized metadata that gets turned into a hash, and then the invoice is generated with that hash, so after the fact you can verify it. Okay, cool. So we make our hash here, we get our value, and we divide it by 1,000. This is just because the create invoice function will be expecting Satoshi amounts, not millisatoshi amounts. I know it can be confusing going back and forth. There's a lot of bug possibilities in that. But yeah, so we will create the invoice using the value and the description hash. I'm console logging that invoice, and then we're going to respond with this format of PR and then routes. We're just not going to do anything with routes right now. We're just going to respond with the payment request. And once again, this is just like the spec. The LN service takes a GET request and returns a JSON object of the form. This right here, PR, where PR is our Lightning invoice. And then routes, which right now is an empty array. Okay, so that is the callback. There's a callback function, so that looks good. But we're going to need something for this create invoice. Where is create invoice coming from? This is where we need to actually interface with a Lightning node. And this is where things can get complicated. So let's get into that. But actually first, I want to add a .get ignore here, because I see that there's 524 pending changes. I spelled that wrong. Get ignore, and I can say ignore.env and ignore node_modules. This will be useful for when we push it to GitHub. But okay, let's get back to our Lightning connection. So we're going to create an lnd.js file. This is basically going to be expecting a connection that we don't have yet. And then after that, we're actually going to set up the connection by getting an LND connect URI. So let's do this first. I'm going to copy all this code and we will walk through it. And okay, I'm going to make a new file, lnd.js. And I'll paste this in. And let's stop our server. And the first thing I want to do is install this package, lnd-grpc, because this is what we're going to be using to talk to our Lightning node. So npm I lnd-grpc. And so what's happening here from the top, we're using this library, lnd-grpc, and we are defining an lnd connect URI. So once again, this is a URI string that contains the location of our node and also permissions to our node. So it's something you want to keep secret, you want to keep safe. This is why we're going to keep it in our environment variables. So we spin up a new instance of LND, passing in our options to the LND grpc library. And from there we have a connect function here, which will run this function when our server starts up. We try to lnd.connect, and we wait for the state to be active. If the state is not active, we throw an error, because we need it to be in the active state before we can create invoices or do anything. And yeah, if there's an error, we console log that, and basically it just connects. And when it connects, it should show us LND grpc connection state, and it should say active right here. So cool. That's our connect function. Next we have a create invoice function, where we take in the value in the description hash from our endpoint, and we call the add invoice function, passing in the value and the description hash parameters, and then we take that as an invoice and we return that invoice. So let's look at the LND grpc library first. So this is one of my favorite libraries to use to talk to my LND node. It basically abstracts the grpc interface away from you and makes it to where you can start a connection with just a few lines of code. So earlier we were looking at the LND API docs, and this is actually an example they have, a JavaScript example, for calling the add invoice function, or a method. So this is a lot of code to write to be able to call that method. So LND grpc, it makes it to where we're using a lot less code. We just have to make sure LND is connected, and at that point we can call add invoice, though it's nested inside of services in Lightning, so that can be a little bit confusing, but overall very easy to work with. So that's why we use LND grpc. You can either pass in host, cert, and macaroon, which these are location and connection and permissions information, or you can pass in the LND connect URI, which has all those things baked into one. So that's why I like to use this. It's a little bit more simple, and a lot of nodes support it. Your Umbrel node at home will be able to make an LND connect URI. I'm going to be using Voltage. Voltage can do it, and you can also use Polar locally with RegTest, which we're gonna do in a minute, and get an LND connect from that as well. Cool. So that's a bit about the LND grpc. It's just making a connection for us and letting us call methods on our node. The add invoice method is the one that we're going to call, and it's inside of the Lightning service here in the LND API. Okay. But now, where is this LND Connect URI coming from, and where is our node coming from? Oops. So, this is where we need to get our LND Connect URI. We can either get it on Polar or on Voltage. I'm going to do mine on Voltage at the end, but for right now we can do it with Polar. So if you haven't used Polar, I'll give you a quick walkthrough on how to set up. It will take you a little while though, so you might fall behind, because you have to install Docker Desktop. So if you search for Docker Desktop, you can install it on any operating system right here for free. And Docker is a containerization environment. And then there's this app called lightningpolar.com. There's an app called Polar that runs on top of Docker and will allow us to have a local fake Lightning network that we can interact with. So this is what you'd want to get set up with a new network, and I have Docker running right here. All you really have to do is just install Docker and open it. And then I have Polar running on top of it. So my Polar network is already started up here. I've got an Alice, a Bob, and a Carol. I mean, let's spin up a new one though, just so you see how it goes from scratch. So I'm gonna create a new network. I'll call it LNURL Pay Workshop. And I'm gonna add 3 LND nodes. 0 Eclair, 0 Core Lightning, and then I'm going to have 1 Bitcoin Core node. And so now this will create a new network for us. We can hit Start at the top. Okay, so it's starting up, should turn green. Yeah. Okay, so now I'm going to, there's different actions and connection information I can get for each node as I click on them. So we're going to be working with Alice. I'm going to deposit 1,000,000 sats to Alice. Now it'll take a second here. We'll actually have to mine 100 blocks or so to give this funds to Alice. There we go. Okay, 1,000,000 sats to Alice. I'm going to give 1,000,000 sats to Bob as well, because I'm going to make Bob pay us. There we go, 1,000,000 to Bob. Now let's open a channel from Alice to Bob. To Bob, 250,000 sats is good. We just want to have a basic payment flow here. Okay, and then Bob will open a channel to Alice. Okay, now Bob should be able to create an invoice. Let's just say 100 sats. And we should be able to have Alice pay it. So Alice, pay this invoice. Worked. Okay, 100 sats to Alice. Sweet. So our RegTest Lightning network is up. We have channels between these two participants. And so now I can click on Alice and I can go to Connect. And I see here that there's an LND Connect tab, and I can go grab this gRPC admin macaroon URI, or I can actually grab an invoice macaroon URI. This might be all I need, because I only need to create invoices, but I'm going to grab the admin one just in case. And it needs to be a gRPC, because we're using the gRPC interface here with LND gRPC. So I'm going to copy this string. And now I'm going to create this variable, LND Connect URI. I'm going to go into .env. I'll say LND Connect URI equals this giant string. Okay. And remember, this string is secret. You want to keep this very secret. Obviously, this is a fake node. That's why I'm able to show you. But if you use your real node, make sure that you don't accidentally dox this, because that means people can fully and completely rug you. Okay, cool. So that is in here. So now we should be able to both start up our server and see that it's connected, and then hit our callback endpoint and get an invoice. And then I want to see if I can have Bob pay that invoice. So let's do that now. Node index.js. Server listening on port 3000. Oh, we're not calling our connect function. Okay, I need to take connect, and I'm exporting it here, but I need to import it inside of index.js. Just like this, import connect and create invoice. And then after our app starts, I'll go ahead and fire off connect right here. Okay, so let's try that again, restart the server. Boom. LND gRPC connection state is active. Well, let's see if we can get an invoice now. So we're going to go to our callback endpoint and get an invoice. So if I go back over here, I should be able to make this call. So callback amount equals, what is that? 10 sats? 100 sats? Let's see. Boom. We have an invoice right here, it looks like, and it's in the correct format we're expecting. Let's go to LNURL decoder and let's look at this invoice. So I can paste this in here, enter. So it tells us this is reg test. So 10,000 mil satoshis, or 10 satoshis. Nice. Okay. Seems to be legit. Let's see if Bob can pay this invoice. So let's click on Bob, actions, pay invoice. Boom, Bob successfully paid the invoice. Amazing. So already right here, and we also see inside of here, I'm console logging each invoice that we create. So we see that in our terminal. So yeah, just like that, we already have this. This is essentially a LNURL Pay endpoint that is adherent to the spec. We just did that in, you know, what is this, 80 lines plus 38 lines, maybe like 120, 130 lines of real code. So not too bad. But it's working. We're able to get invoices of a certain amount. Let's actually check that again. Let's make sure the amount is working. So let's make it, let's add another 0 and decode this invoice. And we see amount is 100. Cool. So the amount is working. Everything seems to be working. But now, like, what you want is you want to be able to use this in real life. You want to be able to actually scan this with a real wallet. So my goal is going to be to get to that point. So let's go deploy this now. I believe that's the next step. So set up for deploy to render. Okay, so I'm going to show you how to deploy on render. We're going to deploy this server, and then I'm going to put in my real LND Connect URI, and I'm going to attempt to pay myself through Albi. And we'll see if our LNURL server actually works with a real wallet on mainnet. Okay, so here is an article that just shows you very basically how to deploy an application, a Node.js application on render. First, I need to push my current code up to GitHub here. So let's go create a new Git repository. So I'm going to go to GitHub. So create a new repository. I'll call it LNURL Express Workshop. Be public, and we'll just make everything empty here. And I'll be able to copy the command. So I can copy this second command here and add my existing local Git repository and connect it to this remote one. I know that the process can be confusing sometimes. So I need to add everything first. So git add everything, git commit -m, we'll just say initial commit. And then I'll git push, and it will tell me I need to use set upstream origin main. Okay, I should refresh this now, and boom, here's all of our code. Cool. So now for render, you will go to render, what is it? I guess dashboard.render.com, and you'll need to create a new account. I just made my account, I believe, with GitHub, and just connected my GitHub. And once you do that, you'll land on this blank screen where there's different projects you can start, and we're gonna do a new web service. We're gonna do a new web service. We're gonna build and deploy from a Git repository, connect our Git repository, and then we'll fill out this form. So let's go through that. New web service. So build and deploy from a Git repository. Now I can find my newest one, LNURL Express Workshop, and I'll connect to that. I'll give it a name, Express Workshop. It's on the main branch. We don't need to put anything in source. The runtime is correct. We don't need to change the build command. The only thing we need to add here, which I show this in the screenshot, is node index.js. So this is going to be our start command. It's the same start command that we run locally. Node index.js. Okay, and we choose the free tier here. So it's very nice, we get it for free. Cool. Let's create a web service. Okay, so there will be I think this will build, but there will be an issue right off the bat. And that issue is we don't have our environment variables in here. So I'll show you how to add those. Let's just see if it builds here first. Uploading build. Build successful, deploying. And it'll tell us here, it says it's in progress. It'll tell us once it's finished. And once it's finished, it'll be available on this URL right here. Okay. Okay, there we go. So it's running, and we get an error. Of course, this is because we don't have LND connected, but let's just see if our root endpoint works. Okay, I'm alive. I am alive, and it works. Sweet. So let's add our environment variables now. I can do this in environment tab, and I'll do add environment variable. And so first of all, I want to copy this and make this the backend URL. It's equal to this value. And now I'm going to add my LND connect URI. And I'm going to add my real one here. I have it off screen because I want to keep it secret. And I'm actually going to pull this off screen for a second just to put it in. Okay, cool. So it's added. I can save the changes now. Cool. And let's go back, and I believe we'll want to do a manual deploy and just say clear build cache and deploy. Let's see what we had next on the slide. So setup deploy to render. Oh, that's the last slide. Okay. So now here's the part where we try and test and prod. So let's see if it deploys here and it actually connects to my real Lightning node. Apologies, I came in a bit late. Where can I find a link to the slides? So the slides are right here. tinyurl.com/LNURL Pay workshop. So almost finished with the project here, but I'm also going to have this workshop, just like all of our other workshops, is going to be on YouTube. If you go to youtube.com, you can find our YouTube channel here, PlebDevs. and this is where we put all of our workshops and videos and stuff like that. So you can follow that after the fact. But yeah, this is a link to the slides right here. LNURL Pay workshop at tinyurl.com. Sweet. Okay, so after redeploying with my environment variables, I see here our server is listening. I see that the LND gRPC connection state is active. And so this was the LND connect URI from my real node. So that means we're on mainnet now. Kind of scary. But let's go and see. Here's our root endpoint. If I go to /LNURL, I can see the callback. I see min sendable, max sendable. Let's see if we can get a real invoice. So I'm going to go to callback. Amount equals, let's make a 10 sat invoice. Okay, here's a real invoice. It appears to be from my server. Let me see if I can pay it with Stacker News. So go to withdraw, invoice, max fee. I actually have a channel with Stacker News, so this should be 0. Let's see if I can get away with 0. Okay, sent 10 sats with 0 in routing fees. So I just made an invoice for my LNURL endpoint and I sent it from my Stacker News balance. So that works. It's all on mainnet. Now let's actually try and get the LNURL and see if a wallet can work with that. So if I go to /get LNURL, this will give me the LNURL string. And let's double check this and decode it. Okay, this decodes to our callback and we get all of our information here. Now, I'm going to turn this into a QR code and I'm going to pay it with my Zeus wallet. So I'm going to take the same string and we'll go to some QR code generator. QR code generator. This one, put in a string. Okay, and it creates my QR code here. Now I wish I could share my phone screen. I can kind of show you. I'm gonna open up Phoenix Wallet. And I'm going to go to scan. So here's my phone where I'm about to scan this. So scan this QR code. Okay, and now it's showing me how much do you want to pay. So let's pay 11 sats. Boom, sent. So not only am I able to get an invoice manually from my LNURL Pay endpoint, but I can actually just scan the raw LNURL with any wallet. Let's try this with Albi. I can take this and open up Albi, send, and I can put in an LNURL. And let's see if I can send 21 sats to myself. Albi usually takes a long time, so we'll see if this actually works. Probably finding a route. Oh, can you see this pop up on my screen? Yeah, okay. Come on. Well, I know it worked with Phoenix, but I also know I have a direct channel with async, I believe. So this might be an issue with Albi's node. I might not have a good route to them. And also another thing is we're not putting in any route hints yet, which is something you can do with LNURL Pay. We're just keeping it super basic right now. Oh wait, look at this. It just went through. So LNURL Express Workshop minus 21 sats. And we have the pre-image. So if we have the pre-image, that means it was paid successfully. Okay, so it just took a second to find a route there, and my balance is 1290 now, so cool. That seems to work. Man, so there we go. That is a free LNURL server. We see my invoices are console logging here. And so in just about 130 lines of code, we just built an LNURL Pay endpoint that is talking to our own node, or maybe you have it set up with a reg test node. And so that was pretty damn simple. So now I guess homework for you to take home, besides doing this project, is, you know, take some time and re-review LUDs 1 and LUDs 6, see if it makes more sense now, and actually check out the other things you can do with LNURL. We've got channel requests with draw request. We've got auth, which PlebDevs has actually done an auth workshop. Hosted channel request, sign message. So yeah, there's a bunch of functionality we can do here with LNURL. But a popular thing that I'm sure you want to do, and we have all the foundations to do this now, is to create actually an LN address. So I think it's lnaddress.com. Should be an overview of, no, not that, okay. Lightning address.com, that's what it is. So here you can learn a little bit more about the spec. Let's see, do we have docs? Read documentation. Yeah, so basically the lightning address, just, you would basically need to set aside another endpoint that has the same exact functionality as your LNURL Pay endpoint. But it would need to be in this format, where you have a username at the end and then a domain at the beginning. This is what makes up the lightning address. And then look at this, we get back the same response with an additional property, it looks like, comment allowed. And that is it. That's all you would need to do to have your own LN address. And of course, here we have this LNURL Express Workshop kind of URL that's a little bit ugly, but you can upload your own custom domain. So like mine is bitcoinpleb.dev. So I could turn this into austin@bitcoinpleb.dev or something like that. So lightning address is very easy to add on to what we have so far. But sweet, okay, it is working. So yes, thank you for coming. If you're here live, I hope this is helpful. Once again, the slides are public, they will remain public. The repo is public and working, and it will remain so. If you have questions or need help, reach out to me in the PlebDevs Discord. I have a link to join the Discord in the description of this on YouTube and Twitch. And yeah, just thank you for coming, and until next time, look out for a workshop next week, and we're just gonna keep building.